This is Chapter 5, Set E, Problem 3. So as for Berkeley freshmen, the average GPA is around 3, and the SC is about 5. Now, whenever I read a problem, I like to go ahead and write down the information they gave me. That helps me figure out what formulas to use and what I need to do. So the average is 0.3, the SC equals 0.5. It tells me the histogram follows the normal curve. Okay, that tells me I'll be looking at Chapter 5 formulas, and then formulas for the normal curve. Estimate the 30th percentile of the GPA distribution. Now, anytime you talk about percentiles, that tells you what area is to the left. So I know it's a normal curve, and I know I'm looking for something that has 30% area to the left, because that's what percentiles always tell me. So I'm going to ask, what GPA score lines up with 30% area to the left? Now, we can't go straight to our x values or straight to our GPA values. We first have to find a z value. So what z value will have 30% area to the left? For that, I'm going to go to my normal table, and I'm going to look in the second column, the areas for something close to 30%. It looks like I'm somewhere here between 29.12 and 30.85, which means that my z value is somewhere between negative 0.55 to negative 0.5. If you want, you can pick either one of those and be fine. You can pick the average of those and be fine. Either way, your answer will probably be slightly different than the textbook, because they'll probably use a calculator to get a more exact value. But as long as you're close, you're okay. So let's try what happens if I do negative 0.5. So let's say z equals negative 0.5. Now I have to try and figure out what's the GPA value or what's my x value that matches that. Now, if you remember, we have two formulas for the normal curve. X equals our average, not x equals, z equals our average minus, I keep trying to write the other formula. Z equals x minus the average over our standard deviation. So that's one formula. Now, you don't have to memorize both formulas because it's just rearranged. So we can rearrange it to get the second formula. So the second formula, x equals our average plus z times the standard deviations. Now, if you don't remember enough of your algebra classes to remember how to rearrange that equation, I just multiply both sides by the standard deviation and then added the average to both sides. But if you don't remember how to do that, just memorize both equations. That will work too. Also, you can remember that z always tells you how many standard deviations you are from the average. So if you do the average plus z times the standard deviations, you should get back to x. With that in mind, though, what is our goal here? We're trying to find our GPA value. We're trying to find an x value. So this is the formula we want. So we'll do x equals our average of 3. Oops, I wrote 0.3. It was just 3. X equals 3 plus z, which is negative 0.5, times my standard deviation, which coincidentally, a complete coincidence, also happens to be 0.5. Let's see what this gives me. This should give me 2.75. So if you have a GPA of about 2.75, then 30% of the people will be less than you. Now, you might ask, what would happen if we chose z equals negative 0.55? Then what would x be? So then x would be equal to 3 plus negative 0.55 times 0.5, which gives me 2.725. Notice my answers are close, but not exactly the same. And if you happen to pick the average of the two values, so if you choose z equals negative 0.525, then x is going to be equal to 2.737. So you can see that no matter which value you get, you'll get slightly different GPA values, but they should all be close. On the exam, I make sure that you have enough wiggle room that no matter which of these you chose, it should show up as the right answer.